In today's video, we're going to look at Chapter 5, Lesson 3, which is on equivalent rates and ratios, and our goal is going to be to use 4 different methods to help us organize and find equivalent ratios. Before we can look into those methods, we need to know what exactly equivalent ratios are. Equivalent ratios are two ratios that name the same number. So in other words, they are two ratios that are going to be exactly equal. The 4 methods we're going to look at today are using a table, a double number line, a scatter plot, and equivalent fractions. So again, we see that link between ratios and fractions, which should help us out as we continue moving forward. The first method we're going to look at is looking at a table. At Hickory Middle School, it says 3 out of 5 students chose pizza as their favorite food. We want to find 4 ratios that are equal to this ratio. Again, this is just a way to help us organize what we have. So if I'm looking for an equivalent ratio, I want a ratio that names the same number. So whatever I do to the top, for example, let's say I do 3 times 2 to get 6 for the number of students choosing pizza. Well, if I have 6 of the students that chose pizza, then my total number of students should also be found by multiplying 2, and that would tell us that we have 10. Notice what should be true in my table. If I look at this ratio 6 to 10 and I write it in lowest terms, it would be 3 to 5, and that needs to equal my original ratio in order for the two ratios to be an equivalent pair. Now I could do the next one times 3, so I could do 3 students times 3 to give me 9 students choosing pizza. Well, then I have to take the 5 total students and multiply that by 3 also to get 15. Again, to make sure that my solving was correct, if I divide 9 by 3, I get 3. If I divide 15 by 3, I get 5. So 3 to 5 is still my ratio there, which is what I want to be true. Sometimes tables will follow a pattern like I'm doing here, going up by 2, by 3, and I could go on by 4 and 5 at the end. What I have to remember is, just like fractions, any equivalent ratio, as long as I multiply the numerator and denominator by the same thing, are going to work fine. So I could skip all the way up to, let's say, 11. I like to multiply numbers by 11. 11 times 3 is going to be 33. And then 5 times 11 is going to be 55. So 33 to 55 would also be an equivalent ratio. And let's say I do 20 for the last one. I could have 3 times 20 would be 60. And 5 times 20 would be 100. Again, if I write that in lowest terms, I'm still going to get 3 to 5 as my ratio. Be dividing by 20 again. So as long as all of the ratios in my table equal 3 to 5, I know that I have a table full of equivalent ratios. In the bottom example, it just goes to show us that we don't always need to use multiplication. We could use division as well. So if I start out with the ratio 40 to 60, notice my ratio again goes up and down. The ratio next to it I could find by dividing by something. Well, I know I can divide 40 and 60 both by 10. If I divide 40 by 10, I get 4. If I divide 60 by 10, I get 6. So 4 to 6 would be an equivalent ratio. Notice again, if I write 40 to 60 in lowest terms, well, I can divide it even farther. I could divide each by 20. So let's say I divide 40 by 20. Well, 20 is going to go in twice. 20 is going to go into 60 3 times, so 2/3 is an equivalent ratio. Again, I notice that 2/3 and 6/4 are equivalent as well. All the tables that I create, or all the ratios that I create here should be equal. Besides just going back up to 40, I could even start from 2. Now that I have 2, I could multiply 2 times 3 to get 6, and I could multiply 3 times 3 as well to get 9. Now notice, there's no number that I can take that's going to allow me to go from 6 to 40. I'd have to be a decimal number. However, I can still prove that they're both equivalent ratios. 6 to 9, if I divide both of those numbers by 3, gives me 2/3, or 2 to 3. If I divide 40 and 60 both by 20, I'm going to get 40 divided by 20 is 2. 60 divided by 20 is 3. So they are equivalent ratios because they both can be reduced to the same number. The second method, the double number line, we saw in class the other day related to ratios. Here we're just going to again organize our information in a different way. It says that Todd earned $7 for each hour he works. We want to know how much he will earn for $6. Well, if I start filling in hours, I have 1 hour, 2, 3, 4, 5, and 6. Notice that if he works 1 hour, well, straight below it should be $7 because he's going to earn $7 for each hour. Well, if he works 2 hours, it's going to be $14 because he'll get 7 for each of those hours that he works. If it's 3 hours, it's going to be 21. I should notice a pattern. I'm looking at multiples of 7, so next is going to come 8, 28. Next is going to come 35. And finally, I'm going to get 42 if I work for 6 hours. So he would earn $42, and I used my ratios to help identify that. The next method I'm going to look at is the scatter plot method. It tells me that Sonia can read 12 pages in 8 minutes. At this rate, we want to find out how many pages she will read in 40 minutes. Well, I'm going to organize my information. I'm going to put the minutes on the bottom. So I'm going to start with 8. I'm going to move it down to the second line just to save myself some space. So then if I count 2 more lines, this line is going to represent 16. The next one's going to represent 24. The next one 32, and the last one 40. Well, I know that if she reads for 8 minutes, she's going to cover 12 pages. So I'm going to put a dot here, and this line is going to be represented by 12. If she reads for 16 minutes, she's going to be able to double this value. So 12 is going to go all the way up to 24 at that point. So my pattern going up the side is going to be 36, 48, and then 60. So if I match those up at 24 minutes, I'm going to be able to read 3 times as much as I was able to read here at 8 minutes. So 12 times 3 is going to be 36. Then at 32, I'll give another color just to make this stand out a little bit. At 32, I'll be able to read 48 minutes because 32 is 4 times 8. 48 was 4 times 12, and at 40 minutes I should be able to read 60 pages if I go at that same speed, because 8 times 5 was 40, so I'm going to do 12 times 5, and that's what brings me up to 60. The last method is equivalent fraction method and shows the link between ratios and fractions. It says that Jake earns $19 for working 3 hours. At this rate, we want to know how much he earns for working 18 hours. Well, here I'm going to look at my ratio as a fraction. If I have $19 for every 3 hours and I want an equivalent fraction that has 18 hours on the bottom, I need to think about how did I go from 3 to 18? What I had to do to the number 3. I had to multiply it by 6. I know from equivalent fractions that whatever I do to the denominator, I also have to do to the numerator. So I'm going to do 19 times 6, so I'll find some spare room on my paper. 6 times 9 is going to be 54. 1 times 6 will be 6, plus 5 is 11, so it will be $114. Now when you go on to the next 2 problems on your note skeleton, you can choose any of those 4 methods to help organize your information and find out, but you do have to show some type of work. So here, this times 6, this is the work that I'm using to show equivalent fractions. How did I go from this original fraction, $19 in 3 hours, to my final answer of $114 for the 18 hours? When you're calculating or looking at your work, I need you to also stop and pause and remember to self-evaluate using the numbers 0 to 4 to show how well you understood each of those examples. And then you must fill in questions, comments, or concerns to describe how you felt as you went through these problems. And we will go over these in class tomorrow.